Dear student, in today's session we learn standing wave on a string. Consider a string of length L stretched under tension T between two fixed points. If the string is plucked and then released, a transverse harmonic wave propagates along its length and is reflected at the end. The incident and reflected waves will superimpose to produce transverse stationary waves in a string. Nodes are formed at rigid end and antinode are formed in between them. The number of antinodes on string is equal to number of nodes minus 1. The velocity of transverse wave on a string is given by formula under root T by M. So in this formula, T is the tension and M is the mass per unit length, or it is also called as linear density. Now here, frequency of vibration, we can write frequency of wave. So it is given by formula V by lambda. Or we can write V under root T by M. Then we get a formula 1 by lambda under root T by M. Now we consider first three mode of vibration of string. So this figure shows the first mode, second figure shows second mode, third figure shows third mode of vibration. Now for first mode, means the fundamental mode, number of loops is 1. So we get two nodes and one antinode. So distance between two nodes is lambda by 2. So we can write, so here L is equal to lambda 1 by 2. So lambda 1 we can write 2L. So the frequency of vibration of string is given by formula. N1 is equal to V by lambda 1. So we substitute V is under root T by M. So and instead of lambda 1 we substitute 2L. So we get a formula 1 by 2L under root T by M. This is a fundamental frequency, as well as this is also called as first harmonic. Now for second mode of vibration, number of loops are 2. Now here the length of the string we can write is equal to lambda 2, because here distance between these two node is lambda by 2 and these two node is lambda by 2. Lambda by 2 is lambda. So this length we called it as a lambda 2. And so frequency of vibration N2 is equal to V by lambda 2. So V we substitute under root T by M and lambda 2 is L. Then we get 1 by L under root T by M. So by multiplying and dividing by 2, we get this formula. It is equal to 2N1. So the second frequency is 2N1. This is called as 2 is coming, so second harmonic, as well as it is called as first overtone. Now for third mode of vibration of string, three loops are there and each loop having a length lambda by 2. So here 3 into lambda by 2 is the length of the string. So we can write here length of the string is equal to 3 lambda by 2. Now we can write lambda 3 by using that 2L by 3. Then third harmonic means we can write the frequency of this mode of vibration is N3 is equal to V by lambda 3. We substituted as a root T by M and lambda 3 as a 2L by 3. Then we get this is as a 3N1. So this is 3 is coming, so it is called as third harmonic, or it is coming after the first overtone, so it is called as second overtone. Therefore, in general, we can write here we get n, then we get 2n, then we get 3n. Then if I consider the mode with the 4 loop, we get 4n. The mode with the 5 loops, we get 5n. So it means that here we all the harmonics are present. Means string vibrate with n, 2n, 3n, 4n, 5n, and so on. So here it vibrate with integral multiple of fundamental frequency. So all harmonics are present. Now let me learn the next article. Laws of a vibrating string. So we know the fundamental frequency formula is equal to 1 upon 2L under root T by M. So the first law is called as law of length. So it is the relation between N and L when T and M are constant. So we can write fundamental frequency of vibration of stress string is inversely proportional to its length if tension applied to it and the mass per unit length are constant. So here it is mean that NL is equal to constant. So we can write N1 L1 is equal to N2 L2. Now the second law is called as law of tension. It is the relation between fundamental frequency and tension. You can see here by formula fundamental frequency of vibration of string is directly proportional to square root of tension if length and mass per unit length are constant. So we can write it as a n upon root t is constant, or n1 by n2 is equal to under root t1 by t2. Now the third law is also called as law of linear density. The fundamental frequency of vibration of stretched string is inversely proportional to square root of mass per unit length or linear density if vibrating length and tension are constant. So n is inversely proportional to square root of m. This is the formula. So we can write here n into root m is constant. So we can write like this way also, n1 by n2 is equal to root m2 by m1. Now here linear density small m is mass per unit length, and here mass per unit mass, we can write density into volume divided by length. So by solving this we get, so linear density is area into this row. So area is pi r square, this is the cross sectional area, and density is rho. So instead of this small m we can write pi r square rho. So we get this formula. So by using that, we can write two laws, law of density and law of radius. So law of density is fundamental frequency is inversely proportional to square root of density. And second one is law of radius. Fundamental frequency inversely proportional to radius.